False alarm. So we're gonna have a coffee break because I'm gonna make another mug of coffee. Just a second. A coffeeholic for instant coffee and any kind of coffee. Any kind of coffee, I am in. As long as it's coffee. If it's coffee, it's coffee. There's no such thing as a coffee that's not that cannot be classified as coffee. It's the point of calling it coffee because it's classified as coffee. Coffee is nice. It's alright. It comforts me. It depends though. Sometimes I do want iced coffee. Depends. But warm coffee is also good. It's comfortable. So anyways, yeah, coffee break. False alarm. Eto. Sorry for abruptly ending the stream earlier. Scheiße. So yeah, it was uncalled for. I thought my grandparents would stay for the rest of the time, but no, they needed to go somewhere else. And then, there you go, I had my time to be able to stream. So let me just get my earphones just a second. So yeah, I'm just gonna wait here for like a few minutes until I finish my coffee so that I can I have an audience. It would be useless to stream without an audience, wouldn't it be? So yeah, I'm just gonna wait for my audience, and I suppose that there are still no audiences. Yeah, no audiences. So yeah, we kinda have to wait. So coffee break. That's why we have our coffee break. Coffee break ko desho. Just a second. I'm just gonna put my playlist on here. So yeah, yeah, coffee break. So yeah, coffee break. This is awkward waiting for an audience. This is not how I operate, but hey, who cares? Don't forget to refresh that. That sometimes doesn't refresh by itself, and there ends up some so yeah. Coffee break ko desho. Yo, nope. Ish, maybe, who knows? Nah, not feeling down. Just tired. Very tired. This year's been rough already. Yeah. So, last night, if you asked me that question, it would have been a different answer. Like, seriously, I found out that, I found some information. Let's just say that, my relationship, that's now dead, I might have had a chance to fix it, but I lost my chance, and that's sad. But hey, that's the past. Not saying forget, but if I get clinged on to the past, nothing's gonna happen. So here I am, streaming like nothing happened with coffee to comfort myself. So, coffee break. How many minutes? So, yeah. In a few minutes, I'll start. Yep, it's the past. Yeah, in a few minutes, I'll start. Yeah, coffee is nice. That's also a valid choice. I used to drink Swiss Miss. but they don't. My grandparents don't buy Swiss Miss that much anymore. So yeah, I'm stuck to coffee. Plus, it gives me energy, and you know, it calms down the thoughts. I overthink a lot, and coffee helps. The lion does not concern himself with the shaking, with the shaky hands. So yeah, caffeine go burr. Exactly. So, anyways, let's start. Let's start. So, yeah, here's the Railib stuff. And, just a second. Oh, yeah, generators work now. Generators work now. So, where is it? Fun fact, I've had the Railib bindings before you were on my channel. Because I made a script to generate bindings for me using cindex. So you just call the oh wait, I did not check because I updated the macros. Maybe no, it doesn't use the macros anyway. So it generates. Oh, actually, I just a second. Oh, yeah. So make me just oh right, just a second. How do you undo pi index anyway? Pi env, not index. I can't. Just a second. So my system has. You know what? I'm just gonna. Cause not seen. Clang. I meant. There we go. And now it should be able to. There we go. So PyEnv. I also just used it. I don't even know how to use it yet. Because I use SpotDL to download music on Spotify for free. So it needed an older version of Python because some of the packages don't support the recent versions yet. So PyEnv is basically like a version manager for Python. Think Node.js, but worse. Yes. Think the Node packages, but worse. Anaconda, yeah. I haven't used Anaconda myself. I never used environments, to be honest. I just used requirements.txt, let the users handle it. In fact, I've got I've got an example here in my Python programming language. Yeah, there is just that file. That file. So yeah. So now that we've got that running, I can show you the automatic bindings. So really, so here's the bindings. So I'll explain it to you. So this is the file that's gonna be read. That's the bindings that we're gonna generate it for. This is the wrapper. It's even there, MiLa wrap.c. So that's the wrapper, the bindings, if you will. And that's it. I just based it on raylib.h. It doesn't touch this actually. This is the only one that's touched because variadic functions aren't supported yet, which raylib does have, and I just ignore it. And I only put some select functions that I use in there, and then this gets generated for me. Yeah. So if I open this, tons of errors. Let me just calm it down. There you go. That's also valid. It's two subdirectories down. So 2 directories down. Whoops. So yeah. As you can see. So that's probably because in the make file, I specify the include path directly. So that's why I didn't need to specify the full path here. So clang D gets all rustled up because it can't find that the file because I didn't put a .clang in the JSON file thing. So yeah, as I said, no type checking. So if the user gives the wrong type, good luck with the seg faults. Good luck with the seg faults. We don't care about the type checking. We just call the function. That's it. That's it. I just call the function and voila. Yeah, we just call the function, and there's this bindings generator. That's true, but in the future I might add a mode or an option to that bindings generator to actually emit like code to type check, because if we don't, yeah, seg faults is bound to happen, and useless errors as well. So here, if you just go down here, you're gonna see that we even support getters and setters for types. And here's the color constructor for the color struct. So when you're here in relib, where's this? That's the struct. That's an allocated struct right there. This was my proudest moment, because that means that C types, C structs, can be initialized within MiLa. You don't need to dive into the wrapper and implement it yourself. The wrapper's generator will generate it for you. So yeah, you can set the X, you can get the X and Y, setters and getters basically for every field. I know, right? And it handles strings as well. So if I go here, if I go to mylarraylib.h, yeah, here's the color struct. That's all of the stuff. And yes, this also gets defined here at the very bottom. Yeah, there it is. It's cursed, but it works. It's cursed, but it works. So what happens is, if I go here and define my own struct, let's say it's a person struct. The usual struct examples in every tutorial ever. Char name, let's say it's size of 100. It's an array. Yes, it can differentiate between arrays and pointers. I think so. Let's see. And now we can just go here. So when after we load it, we can just var person is equal to person, and then my name, and then print the name. Yeah, you can just do that, and there we go. I think so. If we, oh no, that's wrong. Oh yeah, that's the bug that I've been. I remember now. I stopped development on the auto, so I can't really do that yet. But that would work. Yep, there it is. It should have print. Yep, there it is. Wow, that's to. Weird. Just a second. Weird. Suspicious. Oh! Wait a second. No. It shouldn't have printed that. It should have gotten the name. Just a second. It should have updated this to have person now. Yeah, there's that. Let's see. Yeah, we do mem copy the string. No, it's a struct, okay. This is setters and getters. So when we get the name, okay. That's buggy. I see. So struct person. So when we why did it print person? Is my name here? No. It printed person. What? What? Where is... Okay, so there's name. That should have worked. That's what the hell? Performance problem. Look at this. Instead of just allocating and then setting the name, we memcopy this into this. And that's a performance problem. Let me fix that. This is that's the only why did I do it like that? I almost choked on my coffee. What? I'm a fan of debugging using print statements. Oh, my throat hurts. So let's see. No. It's in. Where's the collect types? Yeah, here it is. So, used to using GDB. I'm not used to using GDB. That's because they think that, yeah, it's just a black box basically for me. I just put print statements everywhere and see if where it stops printing, and then I find the problem. The only problem is I can't do that with MiLa anymore because it's 6,000 lines of code. So yeah, I needed to use a sun, which I learned how to use. It's literally just one flag. It's just one flag. So yeah, it was really easy for me to just use. So here we go. Yeah, here's when we create that. That's stupid. Okay, that's stupid. That's just stupid. Stupid. Very stupid. The struct name. Make sure that's a pointer. Malloc. Size of. Struct name. Hey, Nevada came up. Oh no, that's not template strings, those are format strings. Template strings are these. Oh, it's highlighted. I don't like reflection. I don't like reflection. You know why? I got PTSD from using C++ templates. I don't like reflection at all. I do not like reflection. Hey, it's nice to know the types, but I don't need to choke the compiler to tell me what the type is. I don't like reflection because of C++. Reflection in Python is simple. Since it's an interpreted language, you just go import an underscore main, and now you can access the module using underscore main. That's it. In C++, no. No. You both track the types yourself, and then give yourself a migraine for losing track of where you kept that information in. And of course, eat half a gigabyte of memory while doing so, because some of the templates got compiled into runtime code. Yay! Dynamic and static dispatches. Let's go! It's just a headache. Anyways, yeah, I don't like reflection at all. Hey, but they will add quote unquote easier ways to reflect in C++. I hope that becomes a reality, because if that becomes a reality, I will transfer to C++. I will go to C++ land. I'm gonna rewrite MiLa in C++. If that happens. If that doesn't happen, no, I'm staying in Python and C. I'm not going anywhere close. Anyways, where was I? No one uses C++ 26. The most recent one they use is probably C++ 11. The standard. It's just because the compilers, the compiler vendors are just way behind in updating their compilers. Anyways, where was I? Yes. This. So we do those. Now I need to change these dots into those. Yay! Oh, okay. Ooh. Okay, I messed something up. Where's the chicken meme when I need it? Where's that screaming chicken? I need, yeah, I can, yes, I can go here. So color struct. Color new. So let's see. Probably because we do this. Probably because we do that. So we don't need this red anymore. This one, bye-bye, babush. And we just go temp here. Hey, it works! Well, that was easy. So that must have... it's not bad. The speed does not look bad. So yeah, that's cool, that's cool. So it still prints person. Why does it print person? That's weird. What if I print the person itself? Oh, whoops. Oh, there we go. Babush. Because I added more features to MiLa, and that probably, yeah, that probably got more complex. So when we set that, let's go here. Person, yeah, person new. So we just set it, yeah. So we just set it there. Whoa. 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 Okay, that's a problem. Whoa. Oh, we still allocate this. We shouldn't allocate that anymore. Where did that come from? Oh yeah, it increased the FPS dramatically. So there we go. So we set, the only problem is we free it. So we need to do that. Oh, the only problem is it's gonna... oh, there's no memory leaks? That still prints person. Oh! I forgot that gets, what was the word? That gets, overwritten. There we go. So we need to change it here. So let's see, nested structures, pointer type. So if it's a pointer type, we do that. If it's a string though, oh, whoops, too much C. Let's print that. Struct name. So we should see, yeah, we should see the person. Yeah, we do have what? Oh, we are getting the conversion itself. So here we need to, yeah, here we need to get this instead. So let's see. And it's a char star, so we can determine that. So we put this in an else clause. What the hell happened? Else clause. We go here. If f type, that's spelling, is equal to char star. After months of programming in C, this looks weird now. I feel like I have the urge to just put parentheses in there. It looks off without the parentheses now. I'm becoming a C programmer officially. Like what? It just looks off without the parentheses in now. mem copy. Oh, not mem copy. Stir MiLa stir dup. But that should cause no memory leaks now. There's still no oh, whoops. Make and with the debug stuff. No make. Now it's gonna scream at me for wasting some memory. It's there we go. So we got the name. Problem is we don't free this. Oh, that was the reason. Why we no? Still no, it doesn't work that way. Weird. So arrays are handled here, but it doesn't work for some reason. So if we go back into MiLa and put our handy dandy what is the problem? The more and more I talk, the more French I get. Oui, français. 274. Here. Oui, français. So let's see. Where is the problem? There. That is the problem. It's just fun pronouncing French words. I don't want to learn French because I have seen French words and I am scared. Have you seen the word bourgeois? Devenir français. What? Did I pronounce that well? Devenir français. I know how to pronounce French words. I don't know how to speak French. I have seen so many skits. Thank you. I've seen so many skits of people overgeneralizing French words like croissant, over-enunciating it, like croissant, like they're gonna throw stomach acid at any given time. Like, what? Croissant is not bad pronunciation. Like, French people won't even notice that you're mispronouncing it. Croissant. You don't need to say it croissant like you're demanding something from them. On German, on the other hand, it's the exact opposite. You have no reason to sound aggressive. The language forces you to sound aggressive. What's the problem now? Let's see. What's the Guten Tag? Even though it's a greeting, it sounds rough because of the hard pronunciations. Or you can just soften it. You can soften it, but it sounds off. Guten Tag. In German, when you're speaking, it's either you sound too aggressive or you sound gay. There's no in between. That's true. Like, have you seen the fashion of French people? Yeah, their words also have their own fashion statements. With all of the accent ticks on above the letters. And I'm surprised that people don't know about the ending rule. Like, if there's no E with the tick after an S, it's not pronounced. With the it's in 266. There it is. So this, probably because we don't handle it. So that is a problem. What was the problem again? It is, I thought I changed that. Let me just clean that up. No, it's only that. So we need to handle that. So we're gonna use a cursed Python. So we're gonna use a ternary. If I'm just gonna do that. If not else, and then we're gonna put that there. Weird syntax. This is normal for other Pythonistas, but for me it's not. It's no longer normal. Oh no, I'm in the wrong. Suemasan. This one. Ah, wrong one. I meant to do this. So anyways, yeah. It's either people overpronounce words or they underpronounce words. I hate it. Mem copy. That's fine. Yeah. There we go. And ha 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 ha. No. Oh yeah, and where was I? Yeah. My Wi-Fi is being shit. I apologize. I knew I should have. Just a second. I can't see. Shit. Oh no. Oh, I had it backwards. Source destination. That's right. And then size. Right? Yeah. Destination, source. Then size t. Expected void, star restricted argument is type flow. Du bist eins doch scheiße. Oh. I forgot a knob there. Oh, whoops. There you go, Stiang. Let's see. It's a heap buffer overflow. In MiLa person new. How is it a heap buffer overflow? Let's see. In person new. Oh, okay. So let's see. Oh, because we overread. Is it? This should not. Oh, because it needs to be this, the size of this. So I need to add a second type, so it uses store and copy for this. Thank you, C. Thank you for being an asshole. I guess because it's raw memory and it doesn't stop on null bytes, so I have to do that. Hooray. No wonder why developers hate bindings, creating bindings, especially bindings generator. So we need yet another level of interaction here. We need to have another if ternary here. Welcome to Pythonista's hell, where we create abominations that even I cannot describe. Spelling. It's not equal to char star. Otherwise, we go here. Instead of copy, we just go start copy. Now. Was ist Ihr Problem? Yep. Oh yeah, I don't know why, but Python does not have that operator. You have to do this because they decided that that looks better. It doesn't. It looks like a sort. Oh no. What is the problem? String copy is compatible type. Oh, I forgot. This is what I hate about C. Mem copy has. Yeah. So that's the destination as the first argument, and then the source as the second argument. That's valid because in assembly they chose that standard. The destination goes first, then the source, and then additional arguments. In stern copy, no. They decided to follow the name. Why? I'm used to this. Why? I always fuck it up. I always get it the other way around. Scheiße. Was ist Ihr Problem? Expected size T, but got long unsigned integer. Okay, so but argument is of size of value. Ha? Eh? Ano? Destination, and then that's the wait. Then that was right. That was right. What are you yapping about? Ito to. What is the spelling? Let me just print that. Okay, so here we go. Oh, yeah, I have seen it, I think. So let's see. Just a second. Oh, okay. So it has. Okay. So okay. Why? At least it says the type there. So the amount of characters there. So at least we can type check somewhat. So that's actually pretty cool. But at least now we can do that. But we need to normalize the. Yeah, we need to normalize the name. So normalize type arrays. Okay. Oh hell no! You just turned it to pointer. No. This is gonna look ugly. This is gonna look very ugly. Please look away. Please look away. I'm gonna use reggae. I'm about to massacre my performance with regex in Python. How do I use this again? I'm forgetting my key bindings here. Sub. Yeah. Substitute. That's what it means. It's still thinking. Okay. That's it. So replacement, and then that's the what? What? So we replace every apple. Oh wait, what? Pattern, replacement, and then the input. Okay. Sure. Array normalize pattern. At least give it a long name. Array compile. Excuse me? Oh, stop linting. I mean, not even done typing yet. Oh my goodness. This is why I disable the LSP sometimes. Yeah, I'm gonna disable it. Hello? This one. Yeah, there you go. Thank you. Now we're just gonna go here and replace every digit. Every digit. That's it. The replacement doesn't need, is it also, wait. Surely not, right? Yeah. So we can just use it now. Normal, no. Where's the array? Oh, where the hell did that go? Where, what, huh? Remove array sizes. Plural. So now here, is it again? Array normalized pattern. So that's our, yeah, and then text. That's it. I just remove every digit. Yay. So to test it, we're gonna go print. Oh my god, I've been programming too much in my own programming language. Any sizes. So we have char 100. So it shouldn't touch spaces. So if I put that exclamation point there and we aha! Okay, good. It took me a while to realize that this means substitute. Great naming. That's such great documentation right there. RE sub. Yeah, that's great naming. Yeah, let's go. That's very documented. Meanwhile, in the C++ community, I guess. But yeah, in the C++ community, if you wanted to use functional style programming, you need to drown in angle brackets and colons. Because using namespace is, well, that's actually a bad practice. I do accept not using namespace everywhere. The new programmer and I started learning regex. I didn't touch this function. Not once. Not once. You know what I did? I used replace. Like the string replace. Like string, not replace. And I was an idiot back then too, so you know the format strings, right? You can put here and then you go that format test. Yeah. So if test is equal to 90, yeah, like that. In my programming language, the Python one, the first version did not do it like this. That's true. I did not do it like this. What I did was for name value in items. So whatever dictionary that is. So for example, the local scope. Oh. I did it that. That's quadratic. That's quadratic, by the way. Where it's n squared, where n is the number of items in the dictionary. Because replace already loops through the string. That's quadratic. I have this in all of my programming languages back then. So every... Oh, hello! Oh, my friend, he's here. My RL friend. So yeah, I have someone that I'm talking to. Welcome to the stream. So yeah. This was like everywhere in my code base. So yeah, anyways. Voice yeah. So I was fixing this. Need to add that here. I think it was, right? So if we, yeah, there's no space, so we can just go here, char, of any size. MiLa to C, we just go value. Oh, we need to copy that. Hey, you just pass it like that. Yo, that means that I'm getting much more popular. We're getting there. We're getting there. We're getting there. Wow, I can't believe that I am getting much more popular. That's cool. That's cool. That's very cool. That's very cool to know. Wow. V-string duplicate value. So anyways, where was I? So yeah, now that we have that, we can just go here. I know, right? What is the... So we need... Where was the problem? Here. So F type. So we only need to check to replace it with check. So regex is very expensive. So we need to go here. So if it is an array, F type dot spelling is equal to, yeah, we can just override it. Normally, oh whoops, no. Remove array sizes, F type dot spelling. That should not be a read on. Oh no. So yeah, we're gonna do cursed Python metaprogramming. You don't want to follow my rules? Sure, I won't follow your rules as well. I won't follow your rules as well. There you go. Du bist ein Stück Scheiße. Ah. Why? Why did you not instruct me? Person. Oh, that did not remove the... Let me guess. That's true. I'm just gonna... it's cursed and it will be slow for much more bigger projects, but who cares? No one can stop me. No one can stop me. No one can stop me from just creating my own object on the fly. No one's stopping me. No one's stopping me. So this overrides the previous spelling. No one's stopping me. I know my way around this. Do not. Oh, that object type. Wait, what? Yeah, type. Oh, no. What? Chotto. What did I miss? Type. Kind. Nawala? No, it couldn't. Chotto. I made sure. That's why there's no. It's in slots and it doesn't work like that. So we can't do anything. So we can probably just emulate it by just. Boom. That should. Okay. What can I say? What can I say? That did not work at all. Oh. I think it's because oh wait, no. What? Yeah, we do. So, yeah, it's a constant array. Yeah, constant array. It's not a constant array. So constant array. If it is a constant array, we do this. So now, if it's not a character array, we use memcopy, otherwise we use stren copy. The only problem is it's not triggering properly. It's still using memcopy right over here. And it's killing me. Was ist your problem? I don't know what's happening, but if this works... Okay, no, it doesn't. Yeah, that's still memcopy. So, why? Why must you do this to me? So, before I get distracted with the music here, what is the problem? The problem is not problemming. So, yeah, we do detect that it is a constant array. We use memcopy properly. But, this doesn't become true. So why is this not triggering? This is not triggering, but it's triggering me. It's triggering me instead. Why are you not working? Why are you not working? Why? Why? Nande? Why are you not working? Tell me. Varun. Not if type spelling starts with char. So if it does start with char, we use this. But it does not work. It's called a ternary. That's how ternaries look in Python. So if in C, it's condition true, then false. In some languages, even Rust, I think, have this. So if con, so true, if con, else false. That's how it's structured. And this is C. Why? Why is the condition in the middle? Why, right? Why? It's... I'd rather just, if con, then true, else false. That's much more readable. If this is true, then this, otherwise this. Much more readable. But no, languages, like Python, did this. Basically. Yeah. So I'm simulating elif clauses in Python. Because it doesn't support elifs in these kinds of stuff. In C, you would actually do the same with ternaries, but it's fine. Especially if it's not a nested... this is nested, actually. Bad example. But yeah, if it's not nested, it's useful. If it's nested, good luck with people reading your code. And I don't know what happened here. So if it isn't a constant array, we move on to this. Now this, we use this. If it's not char, otherwise we do this. Was ist your problem? Why is this not working? Nicht keine Problem. Oh, that's hard-coded. That's hard-coded. I just noticed that. That's hard-coded. Why is that hard-coded? Whoa. That's hard-coded, by the way. I just noticed that. What the hell? That's a good catch. Like, what? How did I not notice that before? That was hard-coded right there. I did not notice that at all. Probably because I copy-pasted it. No. I didn't. Weird. Imagine that fixes everything. Okay, no. So anyways, memcopy. We use memcopy, and Asan is not happy with that. Oh yeah, this is Asan. It's short for address sanitizer. It's this flag. Oh, it's not here actually, but in the other make file, here in MiLa. Here it is. This flag generates this. As long as you have the address sanitizer library on your system, it will work. So yeah. Scheiße. We can't eat. Oh yeah, we already know that. I don't know why it's not working. Just make sure that it is. Where is it? Okay, so what? Low. Okay. Whoa. Whoa. It's invoking a different one entirely. It's this. Just a second. So anyways, that's why this wasn't. This was the setter logic. This works properly. There's no warnings about this. This is what's triggering it. I am looking in the wrong place. I've been looking in the wrong place. Oh my goodness. I'm not done typing. Stop auto indenting. No. Oh, just. I'm back. So anyways, it works now. I fixed that issue now. We can have arrays now. Yes, finally. Yes. The only problem is that if it's a pointer, it leaks memory. Also, oh, that's not good. Oh no. I'm stuck to the side. That's not good at all. Oh no, that is not good at all. So set. Oh no. Oh great. So the color set. So it's in the rectangle. It's rectangle. That's the problem. Let's see. Not okay. It makes sense because it's a float. Oh. No. It gets promoted. Wait, no. Who cares? So we didn't have any problems with rectangles before. Weird. Why did it only manifest now? Did I change something? I guess with this, but that's only for... That is correct. Ah. No, that is correct. Wait, huh? Huh? Okay, so that's get. This is set. That's what you get for not type checking. And at least I caught that like immediately. So it's in the setters. We need to offset it by 1. So we need to start it by 1. There we go. Ah. So it needs to be 1. Oh, I was an idiot. So that was by... It was intentional that was 1. Okay, I got you now. Oh no! Oh no! No! There goes the performance. It's performing a ton of allocations. Yeah. No, so most of that is from OBS. Never mind. I was wrong. No, most of that is from this. What the hell? Huh? And we leaked to 1 because of that. We are cooked. We are cooked. Definitely cooked. Oh my goodness. Yeah, let me just remove this. Yeah. No, not... But, hey, that's like what? Where is the count? 1,000 food pellets. I think it can even handle 10,000 if we are careful. Never mind. So yeah, it can only handle 1,000 smoothly. So the problem is, it's because, yeah, we use these everywhere. That's the player. And every frame we draw, we create a rectangle. 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 So, rectangle. Anyways, that's probably one of the factors. Yeah, we do that. We need to really reconsider this. This is alright. This is alright. This didn't change. Only... Oh. No. It's always been like that, so no. But creating a rectangle, let's see. There's nothing to... no, that's right. There's nothing really off about it. We allocate. And then we oh my goodness. The stuttering. And then we return it. So yeah, this is correct. Why? It's correct. That's correct. This is correcto. So why is it lagging so much low? Let's see what other possible overhead there might be. So rectangle get x and y should not be that bad. Shouldn't be that bad. Creating this rectangle should also be not that bad. In fact, we can even test that. I literally put test there. Whoops. And then just create a rectangle here. So let's say it's just that is 100. So that should not take a lot. Oh, it did not print. Oops. There it is. Look at that. That should not be bad. Oh. Oh, I know now. I know the culprit. It's in debug. It's the debug build. Look at the speed now. So, oh yeah, we don't set, so it's gonna do max. So if we put 10,000 here now, look at that, it's still getting like 60 frames with 10,000 food pellets unoptimized. Look at that. Hey, some of the food pellets are spawning inside the player. But it's fine. With just a few seconds, we already have like 15,000. And now it's 16. And now, look at that, it's 20 now. Oh yeah, when you resize it, it just, yeah. Look, when I resize it, it just, oh, it does, oh, well, there. It just randomly puts the player and the food pellets everywhere when you resize the window. So yeah. And if you resize the window small enough, the food pellets are gonna perpetually spawn inside of the player. So if you just do that, walk around, and make the windows smaller, it's gonna start lagging as it starts eating like the food pellets. We're still getting like 30 plus FPS, by the way. And there we go. And now we're just gonna continually, yeah, there it is. Every food pellet is inside the player now, and we only have like around 30 FPS. It's still doing quite well. Like what? Look at that. Oh yeah, it calmed down now. Now if I move to the right, now I move to the left. Yeah. It's still fast. Oh yeah, and speaking of fast, is it in generators? Yeah, I think, yeah, example, generators. This is a 5 million generator, look. Let me just clean up the so if I run this 5 million, that's 5 million. So let me highlight that. Oh wait, 15 million? What? Oh no, it's 5 million. Yeah, 5 million each. So it's gonna use this implementation and the C implementation. So this is language level, and then I just wrote it how this would work in MiLa. And look at that, 5 million iterations, 13 seconds, and only 12 seconds. Like what? Oh, I did it. So yeah, after that disconnection thingy, look at this. I changed it to 1 million. So yeah. So now 1 million. Guess how many seconds it would take for it to iterate 1 million 1 million times. Guess how much. I'll wait for the thingy to pop up. So if you guess, so that's it. Are you sure? 5 seconds? Are you sure? Is that final? Okay, I'm gonna run it, and look at this. See that? The C implementation is only 0.03 seconds below the implementation that I wrote in MiLa. That's how fast it is. That this implementation can rival the C code. Like, that means that there's almost no overhead between these two. That it's negligible. I mean, look at that. There was even times that because of my system lagging, that this was faster. That's how small the difference is between these, that sometimes this is faster than this. It's awarding. So anyways, yeah, look at that. So it's fast. And let me just yeah. So I got the generators working. You can print every integer from there you go. And of course, the overhead here is input output. And look at that, only 4 seconds. It only added 2 seconds, roughly 2 seconds. Probably 2.6 or 2.4. Yeah, 2.4 seconds to the total time. We counted from 1 to 1,000 to a million. That's because we yield after we increment n, so that's why it's shifted by 1. And we get that nice rounded number of 1 million. It's cool, dude. It's cool. Because what? What do you mean that I have generators in separate threads? In actual separate threads? Like what? Yeah, let me go. Like in actual separate threads. That's just phenomenal. And speaking of phenomenal, oh! You know what I just got? You know what I just got? We can use threads to make my Raylib example faster. We can use threads now. I just realized that. we just what? So we can go to Raylib and put these, not these. Where is it? So yeah, here we need. This is the main problem. And also, this is just to make sure that the foods are inside the screen. But yeah, I'm gonna remove that now. So yeah, oh yeah, there's an auto mode here. I did not realize that I still have that here. So if I go make and hit V, it's gonna start moving on its own. It's just gonna start moving on its own. That's not me controlling it. So anyways, where were we? We can put this in a thread. So we just yeah, no, it has a calculation. It goes to the, yeah, here it is. So yeah, there, that's the code there. We just calculate the nearest food. That's why it's also wait here. Var check is equal to just a second. Make. So in here, we check for each, yeah. We iterate to every food and we check. Yeah, we just do that. Oh, actually, that's not this one here. This is the, yeah, mean distance. Yeah. Look at, I was lazy, so I just put that as the maximum number. So yeah, there's no infinity yet in MiLa. I might change that. So yeah, I just put 1,000 here, and then manually loop through the foods one by one. Yeah, it's not a good. This entire loop is quadratic. Yeah, that's, yeah. But yeah, I just put 1,000 there. Yep. So there you go. That's a thread. We don't need to. It's just gonna start running, and there goes the. Oh, because we didn't. Let me just. Wait, what? That's weird. Probably because we didn't. Yeah, let me just we didn't begin drawing yet. So just to do that, we're just gonna do that once and then end drawing. here. Ah, that's the problem. We need to put it inside the thread. Actually, no. It just bonk. Bonk. Probably because I already, yeah. So we need a lock. A lock. So for a graph lock. Good thing I have that. So we can do that. And then when we begin drawing, we need to acquire the mutex. So we're gonna go thread.mutex lock graph lock. And then we're gonna go here and we're gonna unlock it. Mutex unlock. So I think I may or may have not updated it. So it's mutex lock and mutex unlock. Okay, so that makes sense. So we do that, and now we also need to do that here, so that we make sure that nothing like that happens again. It just book and then it's dead. Is it unlock here? Okay, it's locked. Okay, let's go. Where are they? Oh no, that does not. I can't kill the game. I can't kill the game. Oh, that is bad. Okay, I'm gonna, before anyone gets seizures. What the hell? Yippee! This does not work at all. Let's see where I got it wrong. So, no. We don't synchronize it, and we just, yeah. So we read foods here, but we never consider that if we modify food here and then draw it at the same time, there's a race condition that's gonna happen. So we need a separate lock for modifying the foods and stuff. So food lock. Great. We have multiple locks now. Yippee! Lock. So we're gonna do that, and same for here. So just, yeah, mutex lock. Oh my goodness. Lock, food lock. And then here. At some point, we're gonna probably realize that we should have never done this in the first place, and it would have just been easier to just not do it. Just optimize. You know. It hates it. What's it? Yeah, it's C. No, it's B. No, it doesn't respond to any other controls that I have. It just, yeah. How do they implement games with multiple threads when I can't even... Yeah, that's true. So we have these. What if I created my own game engine that uses MiLa and is focused on just multi-threaded processing? That would be pretty cool. And we use Raylib as a base. That's cool. Who knows? So probably for now, ignore that. So we do have mutex. Yeah. So mutex lock and unlock. So we made sure that the food, when being modified, isn't drawn to the screen at the same time, especially if it's auto. So the only problem is, no, this is where we draw it, and then where we also check the collisions for the player. No, reading the player position should not cause the jittering. Something else causes the jittering. Is it because begin draw? Possible. It's possible, but we already have the graph lock here. Scheiße. Maybe for now, let's get... Oh, frick. A mango just fell from So yeah, we're not gonna do that for now. I am terrified of using threads. I remember I used threads to create like a 3D Minecraft game. Mango trees, huh? There's one, but it's very big and it's older than my parents. It's older than my grandparents as well. Like where is it? Oh, we're actually used to the mangoes falling down. It's that it's getting stronger because some of the fruits are from the top of the tree, and the tree is like tall, like enough for a 3-story building tall kind of tree. And when when the mangoes fall, they just bang, 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 like it's almost close to a gunshot. So anyways, yeah, should still work. Yay! Yay! And yeah, we can set the FPS target, so we can set it as high as we want to, or as low as we want to. So for example, I want to put it at 30 FPS for some reason. Yeah, it will work. Or if I want to put it as high, I'm just gonna spam this. And as you can see, the peak FPS follows. I know there's like a reference here. Draw circle. So, okay, so center. Okay, so we just provide the radius and the color. So, that makes sense because I did call it food pellets. So, let's try that. So instead of that, for now, we're just gonna go. We're still gonna use rectangles because they're convenient. But instead of draw rectangle, we're gonna use draw circle. Where is it? Control C. Go to MiLa arraylib.h and just paste it in here. Boom. And remove the RLAPI, and then there we go. We have access to that function now. So that's how easy it is. That's how easy it is. You paste in the function prototype, and then when you compile, make sure you link to the library that you're binding with, and that's it. That's how easy it is. I'm surprised that no one has seen the repo yet. You just draw circle, you just boop, pop. So food. So what we're gonna do is we're gonna grab the x coordinate and divide it. Add the width divided by 2. So we're gonna go. Actually, it's hard coded anyway. I think it's 20 pixels. So here we're just gonna go rectangle that get x food, and then we're just gonna add. Was it add? Yeah, because it's from the it's from the center, but the rectangles are calculated from the corner. Actually, that we don't need to calculate it anymore. Hopefully, rectangle that get. Actually, no, we do need to calculate it because we calculate it using the box. So if it's not centered, the circles are gonna get eaten. So we need to do that. So minus. Yeah, again, corner. So 10. It's add 10. And then the color is marigold. It's a favorite color of a person that I knew. Let's see where it went. So error, just circle up. Expected 3 but got 4. What is the fourth? Oh. There we go. 4 arguments but got 3. 1, 2, 3. What's the fourth argument? Oh, the radius. The radius, forgot. Whoops. So we're gonna have 10 pixels. Where are the circles? I'm eating the food, but where are the They just disappeared. Did I get it backwards? Center X, center Y. Float radius. Oh, that needs to be... Oh, okay. It needs to be... it needs to be integers. Okay, so I need to cast this. F to Y. No wonder. Yeah, that's also like a fatal flaw. You need to cast that manually for it to work. Otherwise, there we go. Wait, just a second. Yeah, yep. There we go. We got food pellets. Hey, that looks cool. They're now circles. It would be also amazing if we randomly chose like a shade of marigold. Yeah. Food pellets, actual food pellets. And then I love it. Just hello world, box. Hello world, box. Just box. So yeah, hello world, yeah, welt, yeah, box. Hello world, box. This zoom tool is my favorite. I love how I can just whoop. I can just zoom in into a random part of the screen like immediately. Comedic effect. Yeah. Box. Anyways, that cat gif is just adorable. Anyway, yeah. Oh yeah, I can close this. Oh, I closed it. Whoops. I meant to put it in that workspace and then boom. People who are afraid of, wait, is it trypophobia or something? Fear of holes. Please don't show. Okay, I thought it was something crazy. Trypophobia. Okay, so I was close. Yeah, I know, right? It just scatters. Whee. Oh yeah, and the speed is calculated based on the how fast you can go to any sides. So no matter how big the window is, it will always go to the other side at the same time as if it were small. So, okay. Oh, there it is. So, if you measure how long it took to go to those sides, it's the same if you measure, yeah, so see, it looks faster, even though it's literally just going at the same speed relative to the window. So yeah, that's a cool part. Yeah, proportional, yeah. So it's calculated. Yeah. Oh, damn you. Like, those are C types. Those are C types. There's no MiLa type specified in here. This is just a standard header for C. And I still haven't learned how to like take these constants and actually, yeah, transfer them. That's for another video. Yeah, this is just this is not mine. It's not mine. It's from it's from here. Raylib White. Ray White. What's it? White. I know there's like, yeah, here. Ray White. My own white. I just got it here. Wow. What? Why? But why we can use so many threads and processes? Yeah, everything is a thread, or a process. It's just hidden from us. So if I open this, yeah, those are the processes, right? Those are the processes. They're running on separate cores. I think you misunderstood, but everything is almost a thread. If they're not a thread, they're a process. So yeah, these are processes that's running on my system right now. As you can see, Firefox, there's my applications, Alacrity, my terminal, and there's stuff that is a form of threads. multiprocessing. However, I might have described it maybe not accurately, but yeah, these are threads. And there's multiple cores in a CPU because we want to maximize the amount of threads we can run. So back then, threads didn't run on separate cores. It just switched tasks fast. So that's like the CPU going, oh, I'm running program A now. But wait, program B needs some time to run as well. So I switch to program B and then back to program A. Old CPUs used to do that because they only had one core. They only had one CPU core. In fact, they didn't have any cores at all. It's just one block of CPU. It's just one unit. So the CPU was forced to just run tasks part by part. And that's why we have threads. Now we still use threads because they're still useful, because we don't want to explode the number of cores that we need. So the cores just help distribute the processing power of the CPU to the other threads. So there are still threads. That's why we use them. And it allows for programs to run in true parallel, not concurrency, no switching. They are running at the same time. So if I go here and go see matrix, there's a high possibility that this program running right now, my editor, is running in parallel to my terminal right now. Yeah. TCB? What's TCB? Wait, that's a TCB programming. I don't know what that is. Trusted computing. Eh, Oh, I see. Oh, task control block. Is that what you meant? Task control block. So, I'm gonna try my best. So probably it's a system that prevents a thread from getting too much runtime so that other threads can run too. Probably like something like that, because that's what I got from the name. Task control block, yeah. A threading control block actually. So I'm gonna guess what it means. It's something that I just said, like, right? So a thread doesn't just take control of the CPU and allows other threads to run. So it's very essential in operating systems, because if you just let the user's program run indefinitely, the operating system won't have enough time to manage memory and control IO devices. Basically, that's what I got from the name. So don't take my word, because yeah, I just encountered that term, but I'm guessing the meaning just by the name. So yeah, that's not always true. That's where people confuse it. There's no difference between threads and processes. The difference is who manages it. So the processes are managed by the operating system. The threads are managed by processes in user space, basically. I think, yeah, there are kernel threads which are managed by the kernel, but most threads that you can see that are running might be from a process. So the process is basically a lower level of a thread, right? It's just a lower level of a thread. It has more like settings for the kernel to set and stuff. It's basically just a safer form of a thread. While a thread is a lighter form of a process. You don't need entire kilobytes of metadata just to run a thread. Yeah. Thank you for watching my stream and asking stuff. You have been boosting my interactions. Thank you, Yasanshi. So, anyways, yeah. That's what the difference between threading and processing, multiprocessing is. There's practically no difference except who's handling and how much data it stores. Oh. Well, JavaScript also is that way, especially with its. Oh, that's cool. That's cool. Okay. Okay. So spawning your TID spawn, where function arguments. Send a message to process PID. Okay. Oh, okay, so it uses messages to okay. Oh, now that's nice. That's nice actually. That's nice. Okay, good, good. Okay. That's cool, that's cool. Meanwhile, here in MiLa, we don't have any safety against multiprocessing because I designed MiLa to be like C. So if you don't know what you're doing in MiLa, good luck. MiLa is built for experienced programmers basically. Yeah. I think I think they are much more better than me because well, they've been talking in terms that I do not even I cannot understand. And at least I have a person who I can talk to without fearing that they can't get what I'm saying. So anyways, yeah. MiLa is built for experienced programmers. So that means you have to put the safety yourself. You cannot trust MiLa itself to protect you. Although yes, it manages memory somewhat for you, everything else is a gray area. You're not anything besides even memory safety in MiLa isn't guaranteed, especially cyclic references. I didn't add protection against cyclic references because good luck, bro. Good luck, Yesanshi. Good luck on your exam. So, yeah. Where was I? Yeah, cyclic references. Yep. Just like the C, the gun is pointed at your foot. Yeah, that's true. But, unlike C++, at least, it's simple. It's simple. The syntax is straightforward. You're not gonna drown in angle brackets. You're not gonna drown in colons. You're not gonna use templates everywhere. You're not gonna use std colon colon iterator colon or whatever, std map, std filter, and then yeah, everything is simpler than C++. I have seen C++ lambdas. The syntax is mid. I don't hate it, but I don't like it too. I don't hate or like it. It's in the middle. It's in the middle. I forgot the syntax. Was it like this? Or was it like this? Was it like this? So this is the closures, and then this is the parameters, right? If I'm correct. And then I think you cannot specify the return type, I think. CPP lambda. So okay. Yeah, you cannot specify the return type here. You need to you can't even it's an auto because the return type is inferred. Am I right? I think this now. Refresh this is probably broken again. So yeah. The return type is inferred. Why? Why? Why is the return type inferred? Why? Because the type of this is so the type would be if it's C, if it supports C function pointers, so that would be int x. So it would be like that. Yeah, it would be like that. No. Yeah, no, I was right. That. I think. Yeah. So, if you were to I can get this. Yeah, I can get that. So, the example here would expand to this. Now imagine it for functions, for lambdas that use standard types. so let's try that. So std vector, so let's try it. A lambda that sorts an std vector. So the type, so it must also receive an std vector of t lambda. So lambda it is std vector, right? If I'm writing this correctly. Like what? And then now we go array dot begin. If that's an integer, so I forgot how to like. Yeah. Oh, we need to sort it. So how do that? So auto v, and then you just return a is v. So yeah, look at how cursed that is. Yeah, it's very verbose. Oh my goodness, look at that. Oh my goodness. So we use auto everywhere, right? We use auto everywhere. But the standard also says that you need to be explicit about types. Except if it's these types that you're handling with. So there's a gray area. Either you use this or you use this. It's gonna get worse too if you need to use a specific type and you can't use generics. So what ends up happening is you're gonna have, I don't know, string std string. Now you're gonna type here std string. How good it is to be alive. It's way past the screen. It's just what? Speaking. What? Oh, and I just put auto here. But if you're forced, you'd need to Python is for yours. I guess. But types in Python are worse. But in Python, it's actually you just. I forgot. That's in place. So you need to do it like this because sorted is in place. If I am right. Back in my days, that was in place. Yeah. Q. T. There we go. So, I remember sorted being in place. Am I that old? What? When was Python sorted in place? Oh! No. What? I remember. What? Huh? What? I must be misremembering. Yeah. I must be misremembering. So yeah, sorted. That's it. And I think there's I forgot. Python 3-c help sort. So yeah, you can have a key and then reverse. Yeah. So we have the sort function. It uses bubble sort, right? This uses bubble sort. So anyways, that's how you sort in Python. That's it. I think key is just a way to like which. So for example, it's a dictionary. So we're gonna go put ID. So we're gonna have ID here of a numeric type. Oh, I see. So yeah, this is pretty cool. And then if you want it reversed, you just boom, that's what you do, and it's sorted. Yay! So yeah, this is useful unless you have 10,000 entries. And hey, it's not like I'm. Anyways, yeah, it's pretty convenient for small projects. I think there's like I forgot what tool was it, but there's third-party libraries for sorting very large sets of data. So anyways, yeah, I forgot. I know that I forgot. Oh yeah, you can sort strings in Python, because it allows you to compare strings like numeric. So for example, my name, if it's lexicographically higher than let's say Abby, yeah, it's true, because this comes after Abby. And if I did the opposite, yeah, there you go. What way? Oh, whoops, I used the wrong. Yeah, that's why you can just pass it into sort. So if I put sort here and put strings, it's gonna sort them automatically without you converting them into their lexicographical order. So that Andrew Alexia, I don't know a lot of names. Did I spell that correctly? Oh, okay. So if I just oh no, oh, there you go. There it is. It's sorted. You just pass them to sorted, and there it is. I do have names that I can think of, and those are my dead OCs. I never started writing their lore. And Renrayo, the channel, my persona on this channel. Yeah, that is true. I mean, look at the object-oriented programming tutorials. They all use cars and pets and animals. Renrayo. There's also really Salenia. Got to finish them because I don't know how to draw. I'm bad at drawing. I'm very bad at drawing. So anyways, where was I? Yeah, generators. So what if I how do you yeah, you can be good at everything but not the best in even in one of those. If you're good at everything, you don't have a best. If you're good at everything, you don't have a best. I can draw somewhat, but I'm not good at it. I can program, but not that good at it. But thanks to my nerdiness, I got better at it at some point, and I lost my other skills. I traded everything. Oh, that's sad. Yeah, I can't draw anymore. But back in the pandemic, I could draw a face. Not realistically, but I could draw a face with the right proportions, and you would be able to recognize them somewhat. But they're not one-to-one, but you can still recognize it. The person that I draw. So, yeah, now I can't. Now I can only program. Oh, nice. I can't. The best I can draw now is a tree. The best I can draw now is a tree. So, anyways, what can we do? Oh yeah, does that work? Because I did set this to be parsed as an expression. Yeah, that's true. So if I go for each n and then a literal, that should work, right? And put this on top first. Oh, whoops. Make me. Oh, alright. I'll wait for your return if you do return. And we go. Oh, what the hell? Oh, yeah, that's true. Yeah, not. Oh, there. So yeah, it does work. Wow. Yeah. So now I'm just gonna. Will that work? Ano? Hindi ko naisip. That's up. Hmm. That's not a bad idea. But not. Maybe. We don't know. But maybe. Maybe. But. Damn it. We need to update threading because this is a link. This is just, yeah, it's a list. It's a list. Oh, and changing to a linked list would create much more better. Yeah, because we don't need to keep track of the count and capacity. No, we don't need to track of the capacity. We can only track the count. And it's much more simpler that way. And it is of 1 when you are pushing a new thread on it and popping a thread on it. Is still of n. Wait, no, of 1, yeah. Of 1. It's constant no matter if we push or not. And since we're not gonna be accessing too much of the thread anyway, that's such a good trade actually. But yeah, no. No. If we do change it to a linked list, how do we? So if we need to traverse the linked list. Great. We could do no. How do we do that? Batch it so it's always in a low. No, that would make it quadratic. I'm an idiot. Oh wait, we can bucket it. Yeah, we can bucket it. That's true. So at least, so each bucket can hold at least 100 threads, and the ID determines which bucket it goes in. So multiple of 10. So we got buckets 1 to 10. No, 0 to 9. Wait, what? No, yeah, 1 to 10. That's correct. So we got buckets. Wait, no. What? What about 0? 0 will always become 0. So there's only one thread in that bucket. So we toss that away. So 0 would be 0. So if we had like a bucket, so we got a bucket count, so BC 10, and then if we have 10 as a, let's say 23, so it's gonna end up in bucket number 3. It's gonna end up at bucket number 0, and if we have 10, it's gonna also, oh yeah, it's gonna go to 0. So we got buckets 0 to, for some reason, if we created thousands of threads, so those are gonna end up in buckets 0, 3, 6, 4, and 3, and 3 respectively. So what if we just go range 0 to 100? So let's see. Yeah, okay, that's good. So we have like maximum of 10 buckets. 10 buckets, and they're gonna end up from buckets 0 to 9, and we can have to about 100 threads in each bucket, so that would be at 10 1000 buckets. 1000 threads. If we can grow each bucket though, that would we can individually grow the buckets. That might help. So it's still of 1, although amortized, because that is division. Maybe, who knows? Maybe. So even if we do a linear search, the only problem is how do we get the ID in the so we need to keep track of its ID inside the thread context. It's already big enough. Speaking of William Hansen, you haven't subscribed to him yet. So let's go to his channel, their channel, and I'm gonna subscribe to them. I'm already subscribed. Whoops. Ano ba magagawin ko? Wala na akong magawa. I got no ideas left. What the hell? So, GC? Hell no, I'm not gonna implement a GC. Should I? No. I'm tempted to implement a GC since we already have threads. We could implement a GC. In MiLa instead of the language level. Oh, that is true. It is possible. We can. Yeah, we can. I think we can. What? Yeah, we can. Yeah. Maybe. Nah, I'm not. I'm tempted to, but no. Can I just what was it again? Oh yeah. Figure. There it is. Coffee break. Oh. Coffee break. Let's check the analytics. Let's see. Oh, there's someone watching. And the average duration is, what is this? Minutes or hours? That can't be hours. 41 views. The peak was 7 viewers. That's cool. Okay, so coffee break. I'm gonna just a second. So tomate. My third cup of coffee. Okay, the cup is not aligning. Okay, so. Coffee break. We have surf time. We have surf time. Forgot about that. Surf time. I do have it in balance. In time, yeah, there it is. Surf time, get TM, yeah, no. No, a this is already here. Yeah, stuff time that, yeah, so you can definitely just stuff time var, so we get the info last here, and then here you can just grab the vminium in vcommons MiLa. Oh, no, vminium libs init MiLa, and just yank this. Get TM local. So yes, print time. Chata. I think we don't have that. I just realized that we don't have return carriage in MiLa. What? How did I not realize that? If there, okay, we do have knowledge. Good. You can always try the escape codes anyway. So while true. Do that, and then here we can go system clear figment. You know what, let's just figment coffee break. Since that's a string, that's valid, so we can just run that. Coffee break. Oh, wrong. Sample coffee break. Oh no. What? Figment. A figlet. That makes sense. Yeah, figlet was it. Yeah. Oh no. Oh. We never ran this because of that. There we go. This is my local time, by the way. And we can add global time here. What? Oh, GMT. Whoops. There you go. There you go. And we need to be able to just a second. We're gonna use some ANSI shenanigans here. Shall I go now? Skies, no, 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 yeah, yeah, no, 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 skies, no, 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 yeah, 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 no, 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 no. So one should be enough. That should be enough for one. Let's see. We didn't move yeah, /r. So you go to the first character in the line and then we go up. That should. There we go. Yuck. My car. Yeah, yeah, yeah. Yeah, yeah, yeah. Skies. There you go. It's the same thing now. Because that doesn't flush. Or we could just, yeah, I'm just gonna flush it manually. Oh, there you go. Instead of that, we go here and F-flush. F-flush. That should be, yeah, STD out. Would printing out to the screen will actually do something. Let's see. No. Oh, what the hell? Get in there. What? Nope, it doesn't do anything. Oh, I forgot I can do that. Look at that. So we cannot force standard out to clear, and I'm annoyed with that. We need to make sure that standard out indeed is standard out. So okay, it is. Just have to make sure it's not flushing no matter what I do. It's forcing me. Yeah, we don't have enough. Yeah, it's fine. We really need to go print all in. Sad. So we need to go to my. That's the only way that we could put. Yep, there you go. Now it does work. Ay, scheiße! My phone fell from my pocket. So yeah, just a coffee break because yeah, coffee pretty cool. Nice warm coffee. We should drill it. Yeah, we should do that. That would be cool. So like here we can yeah. Oh yeah, scheiße. No. Boop. Pop. Boop. Print on. Started on. Break started. Current time. Boom. Oh, 2. Yeah. Yep. Go. It did not like that. Oh, because we okay. We don't need to. There we go. Look at that. Would you look at that? So if we don't provide built-ins, when we don't provide the current time, we just get the timestamp ourselves. Otherwise, yeah. So we can actually display. We can actually display how much time passed by subtracting these two numbers. But who cares? Damn it! Fine. Fine. I'm not. I just can't half-ass anything. Yo, hello. So yeah, I'm making my sign over there. So yeah, just a second. So what we're gonna do is we're gonna pass here. We're gonna differentiate between. So this will be L time, and then G time. G time, and we're gonna use L time. Why? Oh, that's a float. That's a float. That is a float. Okay. Oh, probably because yeah, I need. Boop. Yeah, now that works. So we're just gonna not display the hour. We're not gonna display anything. We're just gonna do that. And now, not a. We don't. Yep. We just do that. Elapsed time. Boom. That's so cool. Now we have our coffee break counter. Yeah, it's pretty cool. So break started. Easy. Local and global. Or wait, green. Well, I forgot the GMT meaning. But yeah, we got our coffee break counter now, and has an elapsed counter. It's cool. I feel like trolling right now with his count and his tea breaks. I feel like trolling right now. Mr. Azuzin. What the hell? That guy is just charismatic. He is like he's the second greatest programmer since Terry Davis. Terry Davis was a great programmer, God's chosen programmer. If you don't mind. Yeah, Terry Davis is Holy See. Oh, wait a second. I got a project idea. I've got a project idea. Oh no. Most ambitious one yet. Porting Holy See to any platform. Meaning I have to decouple it from the operating system. It's not impossible, but still close to impossible. Every part of Holy See is connected to the operating system in some way, especially the 3D graphics and the way that you can put the models inside your code, having it spin around as well. So that's, Terry Davis was he was the closest person next to Linus Torvalds to create an operating system by himself from scratch. Even the 3D graphics was by him, but was made by himself. That's cool. He built his own operating system with zero. Yeah, closest. Programming god. So yeah, coffee break. Give my give my brain some space to process things. I might be having a headache from too much coffee. So yeah. Oh yeah, I forgot that exists. I don't have a lolcat yet. The hell. Yep. What? That's the lolcat that I know, right? Okay, so we can do that now. Yeah, I know, right? For some colors. It's 23. It pulled the Ruby runtime with it. Why is it... probably a different kind of Ruby. It's weird. Well, anyways, let's go put that here. Oh, there it is. Yay. Well, we can't do anything. Good thing we still still have a few gigabytes in my root folder, and I mean directory, and I still got 100 plus gigs for my home directory. Yep. Oh yeah, I forgot. You can pipe anything into it. Forgot about that. Just so anyways, yeah. Oh wait, I forgot. Yeah, hyper. Yeah. Oh, yeah. I forgot it doesn't work when it doesn't. I don't know why. Yeah. I don't know why, but Hyperland doesn't launch as a window when there's already a graphical. Must be like some conflict with Wayland, because this is Wayland. I don't know why it just seg faults. Did it seg? So yeah, I've got like Hyperland on my other user. And yeah, I just didn't want to switch to Hyperland because I already had like my configs here, and I there's even borders like that. I found out how to do that in searching the internet. Oh, oops. So yeah, Hyperland is it's meh. I mean, I can tile here too, so that's not a problem. So yeah, I didn't really need Hyperland. I'm more of a practical guy. More of a practical guy than a boaster. Yes, I use Arch. So what? If you use Arch, so what? You can play around with configs and that's it. That's like half the Arch community. Half the Arch community just felt a disturbance in the force when I said that. I mean, Arch is good if you're experimenting, but if you actually want to use Arch, it's just like any other distro out there. If you're not experimenting, well, it's just a normal distro. But it is convenient that it's not that bloated. Because yeah, look at that. And the RAM usage, jeez, the RAM usage, yeah, it's not that high. It's cool. Oh yeah, I forgot. I don't have Kause. Do I have Kause? I don't have Kause. Oh, I do have Kause. What's Think? That's new. This is. It just changes. Oh, I see. No problem. Kein Problem, mein Freund. I did not know that there. Yeah, it changes the thought into the thought bubble. So this is like the dialogue bubble, and then this is the thought bubble. That's I just realized that. What? That's cool. So anyways, Kause, coffee break. Oh, whoops. What the hell? There you go. Sure. I think there's like, yeah, I think there's like different arts. But what's the most cursed flag here? What's the worst flag that you can give me for Kause? What is it? What is it? What if I force the Kause to I like to eat burgers? Oh my goodness. What is the cost flag mine point? Watashi no tomodachi. So yeah, what is the worst flag? What is the worst flag? What is the worst flag that you can give to Kause? I am intrigued by your what is the word? Information. My coffee is what? Oh, just reverse what you were gonna say. Just reverse what you're gonna say. Always works. And I can read backwards. That's like a useless skill that I have. I can type backwards. I can type backwards, which is a useless talent. Oh yeah, I might. No, actually, I have tons of time. So take your time. Tomodachi. Or it's just my Wi-Fi going crazy. Sodomized. Sodomized. Moo. Oh no, I don't have sodo. It's just yeah. Sadly I don't have that. So sadly I don't have that, dude. Sadly, I don't have sodomized. How do I how to install cow says sodomized. Yeah, I don't think S. No, I don't have sodomized, sadly. Actually, don't tell me it's not. Oh, wait, how do you, dash F? I knew it. Yeah, it's not. Oh. Oh, cow save off. Let's see. Sudo pacman -s cow save off. Oh, that's sad. What if we search for it? Maybe there's like other difference of. Let's see. Oh hell no. Oh, that's sad. Okay, I see. Cow say sodomized theme. Okay. Let me see it. Where's okay, so sodomized sheep. What's that mean to be? Oh, here's the other one. What's that? Don't tell me. Is that depicting someone loving a cow too much? Wait, yeah, I forgot. I can I can I forgot that I can do that. Where might that be located? In local. Is it include? No, share. I think it's share. Cow. Oh, okay, cow is not here. Local state? No. Include? No, not include. So it's not local. Maybe config. Cow. No, not here. Cow. No. So not that. So where is cow located? Where is this? Like, let's see the description. Description. The description. Where are the cow files put? Stop correcting what I'm searching. Okay, no. So let's see. This is no, that's R, not. So where is it? Okay, so here's. Okay, so where is it found? Voice the. Yeah. So where is it? Where is it? Okay. Oh, here. So it's. Oh, okay. Okay, user share. It's in user share. Oh, I have to pull out. Okay. Slash user share slash share cows. Okay, cows. There it is. Sodomized dot cow. Ah, cow. Oh, come on now. Is it because no? Let's see. Cow. Cow. So let's see. We need to do EOC. End of cow. End of cow. No. Line 5, near thoughts 5. No, do I have to escape this? No, it should not. Why? No. 5. There's. That's sad. What package is this? This is, yeah, Kause. Can I just take, no, I can't really. Really? You know what? I'm just gonna build it. I'm just gonna go build it because I'm just gonna build it from scratch because no. Call that styles. Okay. How do I? Okay, so here it is. No, I don't know. How do I run this? How do I run? You know what? I'm just gonna look at the original. Yes, this is the original. Why is there no make file? Where is the make file? No. Okay. Does it have sodomized? It does not have sodomized. Yeah, it would have been here. Why won't you let me see the sodomized one? Kause original. Kause original. We are gonna find. Okay. Move. Here it is. The original. No, we're gonna. Does it still have? Whoops. Does it have? Where's the where is the cows? Where's the cows? Cows off. Cows. Who is the cows? Is it? Ah, here it is. Sodomized. No. No. It's literally just not there. No. No, hell no. I'm going back in time. I am going back in time. Oh, okay. So uh I'm gonna go back in time. I'm gonna go back in time. I am repositioning. Just okay. Wait, no, I can just view it from here. Oh no 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 no. This. I can like no. I need to. Okay, so I know, right? So rm-rf copy, and then we're gonna git clone. Oh, whoops, wrong one. No. We're gonna clone this with the branch of what it that oh my good. Why can't I? Why? Pop. Did that work? Oh. Or we can just. We are building it. We are I am determined. Git. Branch. Was it? Would this work? Okay, there it is. I am here. Oh. Oh, there's an install sh. Oh, there's nothing here. That make what? It's just decoration. What the hell? Okay, so there is make. It has installed, doesn't it? Yeah, it has. I don't know install. I want to install it. Should I install it? System wide. Okay, fine. I'm gonna install it. Who cares? I don't care if it breaks my system at this point. I do not care. It does not work. There's no. Is there a copy of Sodomize in here? There is. It's. Oh! Oh! I see. Oh, what the hell? Sodomized. Cows. Sodomized. Cow. Why would a couple of lines flag YouTube? Anyways. Let's go! We got it working! Yes! We got it working, guys. Let's go. Woo. Literal double. Oh my goodness. Ah, all of that for a curse. Best coffee break ever. Yes. 15 minutes well spent, definitely. Yes. Hey, that's historical. That's an historical artifact. You cannot condemn me for storing a historical. You cannot condemn me for storing a historical software. Woo! Such an achievement. Oh my goodness. Anyway, where were we? So, we really need to fix something about... Oh, actually, I have... home, local, lib, MiLa, letters. We have this, example. Oh, there we go. Letters that MiLa. I'm just gonna call it letters as well. Save, and it's actually... there we go. So, we can run that. And it's gonna print letters. Albeit broken. So if you just remove that, because we're not even building anything. Yeah, we really need to do that. It forces itself there. So we probably can ANSI escape to clear line. It's 2k. 2k, 0k, 1k. So erase entire line, end of line, this is start of line. So 2k. So we can just go here, print ln. We go to this. We go to that. We go to there, and we will clear the entire line. So 033. Whoops, wrong. 033. 2k, 2k, capital K. Boom. It's unreadable, but it's still it's barely readable, but it's readable. Test ASCII. Whoa, 1 2 3 4 5 6 7 8 9. It works. It works. That's cool. What if we added a sodomized Easter egg? Oh my god, I'm cursed. Anyways, where were we? What's... it works. It works if it works. So if I put my name there, even though it's lowercase, it should... no, we can't. Won't. Oh yeah, forgot. Remove that. So if we do that, okay, I forgot to clear that. Boom. That's my name, Darren. And put like the quick brown fox. Jumps over the lazy dog. So every letter should be tested. There we go. The quick brown fox jumps over the lazy dog. So we got, oh, what? Yeah, no. There's A, B, C, D, E, F, G, H, I, J, K. I can't read it. L M N O uh, P Q R S T U V X Y Z. There we go. Yay! The numbers though. Oh yeah, and J and G looks very close. Especially 6 as well. 6 is here, but it's closed. So yeah, that's G. That's recognizable as a G. I am actually quite proud that this is readable in just 3 columns. Just 3 columns, and it's very readable. I'm surprised. Oh, yeah, and H space only. I know. It's like the letter Q, but we can't add like another column for that, or it will touch the U. Yeah. So basically, it's like that. So it's literally just one more pixel, and that's the difference between Q and 9. So yeah, just those 3 pixels. So yeah, we really need those. And I can set the number of cells in a space. So 4 would be the standard because yeah, a letter has that. So if I do that, it becomes monospace. See, it's monospace now. Yay! I'm gonna add parentheses because why not? Why not? So yeah, we're gonna add parentheses. Imagine me programming with this font. So that's the okay. It's good. Looks good. And now the other side. So we literally just there, done. Yeah. So now it should work. We now have parentheses, and don't forget that we need to put them there. Boom. Parentheses. Print hello world. Oh yeah, I'm gonna complete that. I'm gonna complete the set. So we're gonna have quotes. Quotes would just be like that. Yeah, that would be quotes. Since we use ASCII for printing stuff, that shouldn't be any problems. So actually, since yeah, this is gonna be, yeah, this is gonna look cursed, very cursed. Oh well, we don't need to escape it now, and that not for now. So for quotes, can you just hush you? Can you just hush you? So that's actually, yeah, that's gonna comment that because this is actually a string. This is a string. This is a string. That's called a string block in MiLa. So yeah, that should work. There you go. We have quotes now. So so we can now go here, print ln hello world. Oh, we don't have yeah. Yeah, I have to add this and this. So now what did we add it? Okay, so exclamation point and then the comma. So we're gonna go here, exclamation point. So we're gonna center it. So this, it's 5, so we're just gonna go here. Oh, I forgot the comma. How should we do the comma? Boop. What happened? What happened? What the hell? I just added a comma. Exclamation. Yeah, quotes, exclamation mark, and then comma. What the hell happened? Oh no. Low, are you okay? So that's okay. That's okay. One more. Oh, not you. This. No, what happened? What the hell happened? Oh, oh, just a second. I think it. Okay, what if we try to make this wider? We'll see. Oh, the lowercase letters. I don't have lowercase letters. I forgot. Yeah, we're gonna be programming like we were in the 90s. No lowercase. There it is. Ah, it hit the. There you go. It looks cursed. Oh, that's too low. That's too low. I did not. Yeah. Oops. 4 characters only. Okay, so there we go. Yeah. Print ln hello world. We're programming now. Holy. So yeah, the reason why I have this block quotes string blocks is because of TCL. TCL. If you do you know TCL? If you don't, I will showcase you some code. So that's a ton of folders now. So let's make a script.tcl. So now we have TCL. Yay! I don't have TCL. Forgot. Oh, I have TCL sh. I do have TCL sh. That's okay. So I do have that. So I can just conjure out a. Yep. Oh, whoops. What the hell? Oh, this one. CD project T, and then here we go. We have our script TCL. Yeah. So now we're gonna run it. TCL sh. Script. Yep, there it is. So basically in TCL, the strings are this. That's a string as well. Okay, so I got disconnected again. So yeah, TCL. You can write code in, yeah. So it looks like it's not a code block, but it's still a code block. I mean, it's a string. It's a string block. Boom. See, it's a string. That's literally a string. So yeah, and the way you define functions, proc, you give it the name. So greet name, and then here's the code. You go puts the resign name. So yeah, it's like bash but a little bit better. So now you can just go greet and then my name, and then oh, forgot to put space. There you go. See, that's how you program in TCL. So in MiLa, to do the same, how would I do the same in MiLa? So basically, yeah, I need to define. So in MiLa, you define a function. So fn name arguments. So let's do the same example. Greet name. This looks like it's not a string, but inside MiLa it is a string. MiLa just grabs this as a string. So here you'll see what I mean. Hello name. So now we can just see in MiLa C v function. So any say here, see this? Yeah, it's just, yeah, there it is. There it is. It just grabs it from the source. Yeah, there it is. It just grabs it from the source, and then puts it in a v function value, which can be executed. And then when we execute it in call function, so call function, we literally just parse it. So yeah, there it is. We just parse the body source like that. Boom. That's how you make functions in MiLa. So even though it doesn't look like it's a string, it's still a string. So yeah. See if I go quit. Yeah. You know what's cursed about MiLa? Oh, whoops, wrong. MiLa doesn't enforce semicolons. There I go. Oh, whoops. MiLa doesn't enforce semicolons. So, you can just... boom. Still runs. So, this isn't like JavaScript. It's... I guess. But you will see why it's cursed in a moment. So, let's say we were adding, like... I don't know. We were adding some... oh, actually, no, I think that doesn't... so let's try that. I think it won't. Ah, there it is. See? Even though it's two separate lines, it guessed that it was like that. So that's why it's cursed. So if I were gonna say var name copy and go here name, if I don't put a semicolon there, and I go make a function here, make a lambda. Oh, by the way, this is a fun way of declaring functions or lambdas. If it doesn't have a parameter list, you can omit it. So you can just write it like that. So update, and then that's it. You can omit the parameter names. So that's cool. So now, if I were to make an IIFE, finally got it right. So this returns hello. Return hello. Yeah. It just dies saying undefined function name. Because it's not terminated by a semicolon, it thinks that, oh wait, the user might call this identifier. So I have to check the next tokens if it is something like that. So it finds this opening parenthesis and just parses this as a function call. But if I put it there, boom, it's cool. Nothing happens. Oh yeah, we also have... oh, okay, right. Have you programmed in Rust? Of course, you might have experimented with Rust. So, in MiLa, almost everything returns something. So you can just... that's valid code. So yeah, this is valid code. Boom. Oh, yeah, it's fine. So yeah, look. It runs. So this is called a block expression. So basically, it's useful if the only problem, it's useful if you're doing stuff that you don't want it to get mixed up with other logic. You can just literally do that. The only problem is it's not scoped. I think, yeah, I didn't make it scoped, so just a second, I'll check it. Yeah, here it is. It's not scoped. Oh wait, no, it is scoped. Yeah, it is scoped. So yeah, so if I go here, var temp is equal to 90, if I were to print it outside, it is null. Yeah, as you can see, it's null. So yeah, that's... there we go. So yeah. So, oh, actually, I'm gonna show you something. So, you see this directory, that directory? That is the special directory. You wanna know why? In vminium, remember you can run like MiLa code in it. Yeah, there's the copy of MiLa. If you go here, there's scripts. And if I were to open, oh, what the hell? My mouse just went up. And as a Linux user, I do not want. Whoa, what the hell? Is someone taking over my laptop or something? My mouse just moved by itself. Weird. Okay, anyways. So, oh yeah, I already had it open. Let me just close the other, the other tons of, yeah, let me just close all of these. Okay, so, yeah, so look at this. It's MiLa code that can run in Vimium with event handling. So, you can, this runs every time I press F1. So yeah, as you can see here. So if I press F1, it will trigger this this logic. So type just means, well, you type, it literally types it out for you. So whatever you put in here gets typed as if the user typed it. So this is what is typed. That's the date string. Start time and get tm local. So if I go to vminium, go into insert mode, and then hit F1, and then hit hello. Oh great, it doesn't work. No. Well, that's just sad. That's just sad. So let's try it here. Will it work? Oh no, I have to fix that. Ah, great. But yeah, here. It works. So every time I press F1, it types it for me. So yeah. Pop, and just spam it. So yeah. Oh, whoops. That's cool. The only problem is it's not run properly. So anyways, let's go back to MiLa. So if you wanted to add features to a programming language, what feature would you like it to be? Because I'm just out of examples. I'm just out of stuff to add. I don't have any more ideas to add here. Yeah, here it is. So yeah. MiLa example string. Yeah. Okay, so let's yeah, forgot. Let's add those sentinels, infinite and stuff. So inf and negative inf in C. Hello? What? Huh? Are you seeing this? It doesn't... Huh? What the yeah, so... So let's see. In math.h... Oh. Okay. Uh-huh. There's also is infinite, is inf, is normal, sign bit, macros in math.h. Okay, so Yeah, Google is messed up. I don't know why that happened. So anyways, let's go. Built-ins. Go put that here. Yeah, I know, right? I never encountered nan in C before. What? How do you get nan from C? Huh? How do you get nan from C? That's random. So anyways, inf. We're gonna do inf. V float infinity. And we can just go negative infinity. Oh, we can. Oh, wait, no, we don't. Oh, can we? Okay, will it work? No, it's not. Yeah, no. We don't have unary, so we need to go nin. It's cursed, but we can't. We don't have unary. Printf should handle it, hopefully. So if you have inf, we don't. Oh yeah, it does. Inf dot zero. Inf dot zero. I forgot that. Yeah, negative inf dot zero. Oh, so yeah, at least we have those sentinels now. Ow, we have sentinels now. It's just formatting, because I created my own formatter so that it doesn't need to specify like the precision, so it automatically cuts off extra digits. So like if I go here, go 0. 0.2, 0.3, they're different lengths, I think. Yeah, and 0 point, yeah. So it automatically chooses, oh god damn it, there's no it automatically chooses the precision to print. Yeah, there it is. So if it's not like if it doesn't end with a dot 0, or like if it's like a whole number, as long as it doesn't have that dot, it's gonna add dot 0 to it. So this actually just is 1. It only prints as 1, but because we don't have a dot, we add dot 0. So what happens is when we do inf, which doesn't have a dot in it, so boom. Oh, no, don't worry. If it's an integer, it stays an integer. So it's only for floats. Don't worry, my friend. It's only for floats. And yeah, even if it's a big int, it still is just a big int. So yeah, integers stay integers while floats get special treatment. Yeah, there you go. So yeah, there's also some random stuff. I think there's like, I don't know, but there was some point like this started freaking out, even though it was just, was it 3? Oh no, 2. Sometimes I guess oh wait, I changed it, but yeah, I think yeah, classic. I know, right? I think bonk dot 0. So we need to change that. So in float the string. Yeah. No, that's not how we do that. As C string. There we go. So t float. Yeah, there it is. Float the string. This is our, yeah. Check if there's a decimal point, search or exponent, and then if there isn't, we add dot 0. So we're just gonna check if here we're gonna check if buff sterlen buff -1, if it's not numeric, not is digit, we just return it. We just let it do itself. So oh, that's, oh, I didn't build. Boom, bam, doesn't do that anymore. There we go. Yay! And normal floats. Yeah, it's just a simple check. We just check if the last quote-unquote digit is a numeric. Otherwise, we just let it be. We also support hex, so we can print my favorite number without being suspected. Quote-unquote favorite number. So yeah, we have that. Oh yeah, I haven't showcased you this. Well, we can always test it. So, is 0 greater than infinity? False. Okay, so is it greater than negative infinity? True. Okay, so is negative infinity? Okay, let's see if my computer explodes. Okay, so comparing negative infinity as long as it's less than is always false. Got you. But is infinity greater than negative infinity? True. It's greater than anything, even itself, we believe. Anything. Oh, it's whoa! I just found a mathematical loophole. Guys, infinity is not bigger than infinity. Guys! I guess that is true. So yeah. So now let's try to see if negative infinity is greater than infinity. Of course, it's false. Good. So now we can check if it's greater than negative infinity. Okay. It works now. So that should be true. Okay, good. So yeah, it's great. So by the way, we have methods for strings. So I can substitute parts of a string using patch. So stir.patch. So the string goes here. So apple. Let's say I want to replace apple with apfel because I'm German now. I can. There we go. And yes, there is no memory leaks. Yay! So it's just a simple, and it's not just one replacement. It replaces for every occurrence in the string. Apfel. And it's implemented in C to make sure that it is not. I am back. Got disconnected again. Anyways, now we can patch. We can also see how long a string is using strlen. We can also we can't reverse it. There's no such thing yet. But we can convert it into an iterable string using iString, and it just prints as a string. So yeah, and I don't think you can add iterable strings yet, although I'm planning to do that. It's still like a string, but it has like a to iter method, so we can like for each n. What the hell? Each n. That. It's not an iterable. It's still an array. It's pretending to be iterable, but it's just an array being looped. That's how every iterable is in MiLa before generators. So if I wanted this to be an actual iterator, I would. The only problem is you would need to like you can't so you can't just this is let me just oh my goodness slow down. So before generators, there's no real iterators in MiLa, so that's just an array. So if you look into built-ins, so here's the meta table. It only has get, which allows for indexing it. So if I put this into like a variable, we can now get any part of the string, and we can iterate as well. So yep. Oh no, it's just for this. There's still some very annoying memory complications. So yeah, yeah. When we try to index a string, it yeah it yeah. There's a first A. So I'm still looking forward to fix that. There we go. Beep. Apple. So now, yeah, it's just not iterable string, and you can iterate it as how many times you like. Not like Python, which consumes the iterable, because again, this is not an actual iterable. Every time you call for each, it generates a null terminated array. So what happens is it generates strings, an array of strings. So what happens? Oh my goodness! I keep saying so. What happens? Anyway, basically, what happens in the C code is it has vstring. It just calls vstring on every character. So like jup char a 0 to until the very last until yeah it just terminates it with null. So that's what happens every time you call for each. Use for each on an iterable string. Yes. That's why I don't like explaining things, because I always use those words. I overuse them. I really need to like learn how to talk properly when explaining things. I keep saying those 3 words. So basically, so what happens? Anyway. Who? So anyways. Oh my goodness. Anyhow, this is what happens underneath. Yeah. The problem is that's slow and it's memory if this is long. So I'm hoping in the future to be able to implement an actual generator for this. Which, you know what? Yeah, I'm gonna do it. I'm gonna do it right now. Or not. Yeah. Max time probably 10:30. I might stop the stream by then. So anyways, so new type. Not new type. New method. So we have the globe that should be there. So now oh my goodness, we are gonna have a method. So probably a unary method, because it only needs itself to modify. So we're gonna go here. U method to generator to gen. So now we're gonna this method to turn collections into generators. Now in threading, we need to be able to create threads basically with the same mechanism, but no source. Wait, no, that doesn't make sense. How do we create? But it's still, because it still relies on that, so we can't really. We need the. Wah. Yeah. Wah. 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 My favorite. My brain is hurting. So yeah, we did define my what was it called? My tone just changed there. Anyways, yeah. How do I implement this? I really need to. Oh, okay, that's actually pretty Why didn't I think of that? Just not here. What the hell? Threading. This. So it's either source or we have a function pointer. So type def. What should the function pointer be called? So it's gonna return void, of course. It's gonna receive itself, and we're gonna call it generator. Oh, I forgot that generator. It's gonna receive itself, of course. Welcome to C generator, and we're gonna call it cgen. So this will be null. Either src or this is of set at a time. So we have that. We have cgen. So now when we are setting this, we need to set cgen to false. I mean to null. What the hell? There we go. So the only difference is like, just let me grab this. Oh yeah, I forgot. Bump. Value star native. Oh no. Make cgen. And then we're gonna get the generator. Oops. Yeah, no. We're gonna get the generate. Oh my. Why is there C++ in my C code? No. No. So we need to fix that. So source would be no. It is clang D, so it just pushes me to use that damn thing. Cgen will be equal to C_gen. So this I'm not gonna set it to null. I'm just gonna handle it with a clean up code later. So CNV, and only if we have ctx source. There we go. So that shouldn't always, that should still work. Oh. Bam. Okay, it still works. Okay, that's, wait, no. We're not safe yet. Oh, wrong file. Oh. Okay, there's no. Hello, welcome to the stream. It's working, at least. It's gonna be like what, 12 seconds? Or 14 seconds. It was off by 2 seconds. So yeah, it works. Great. So the thread get healed and thread worker needs to be there we go. So now otherwise we're gonna call ctx cgen. I am not bothered to add. So I'm just gonna pass in the context there. Yep, the stream is delayed. Oh. So that's it. We can do that now. So anyways, in for each, we can now check if go away. Next gen, we need to return. We didn't even set this. So we need to do that. We don't have that. We don't have that. Nor okay, no, that we can free. So let's see. So we need what we don't even return anything. So that should be an int, and we return thread ID. We return -1. Okay, so please don't blow up. Okay, that still works. Okay, that's good. We got make cgen. So yeah, it works. Good that it works. So cgen. Now we need to go in built-ins and now create our function to create that. So what we're gonna do is iter object. First we need to check if this supports iteration, I mean turning it into a generator. So now go here, if has method, oh wait, we don't have it. If iter object, oh what the hell, I don't need C++ here, dude. Objects, method table, and iter objects, method table. That wasn't a method table. You method, oops, method to gen. Boom. So now we just remove the include that was, yeah. So now you method to gen. There we go. So now we just call this. Hello? What do you mean? What? If I swear to God. Oh. It's in 5778. Excuse me, but it is. What? There's literally nothing. Excuse me, I believe that I did that correctly. Oh, I forgot we have to cast it first into a ternary. No, unary. Unary method function. Ah! Stop debating me. Debating me with. What? Unary. Oh. Oh my goodness. Oh, I think I may have to go. Not yet, right? I hope not. What? Struct value. Star. Set a function pointer. Oh no, yeah, it's a pointer, so we do that. Do I have to dereference it? Of course, that goes up. How do we call to iter here? So we. Okay, so you now remember. Yeah, so it was happy doing that, and then boom. Was zum Teufel? Was zum Teufel? Okay. Oh, I see. But this returns. You should. What? Oh, I'm just gonna trust it. Oh my goodness, I'm just gonna trust it. So now built-ins, we need to iString to iter. Yeah. Okay. So now to gen. We're going somewhere. Finally. So we're gonna go here. Was it value? We do return value, right? Yeah, that's what. Yeah. String underscore string thread worker. String gen. We're gonna call it gen th worker. Gent worker. Because why not? Woker. Thread. CTX. Okay, anyways. Return venal. My neck. So we got the thread we don't get the thing that we're iterating with, so this needs to be different. Wait, values. What the hell? Value start, and then thread context start. There you go. So now here we receive the where's the make cgen. So we're gonna receive a value star, which will be passed into oh. Special like me. What? My brain needs a filter. Jesus. It's not wrong though. Oh my goodness. Anyway. Yes. It's not the. Yeah, it's not. It's not. It's not the registry. That's Oh yeah, we need to create a thread here. So, poop, beam. Add special. We don't need add special. We just yeah. So we need the context. So we already received the context, but the worker, yeah, we need a special kind of struct. Whew, I need to really lower down on the caffeine. Anyways, structo the show. What the hell? We're gonna name it cgen th. I'm just gonna go cgen data. There we go, cgen data. So we're gonna receive the context. So thread context as well as the star date. Jesus, data. No, it's already. Cgen data. So we do need to pass it as a pointer because otherwise we can do that as an opaque. So cgen data star cgen data is equal to cgen data star malloc size of cgen data. Yep. Yippee. Yip. Cgen data ctx is equal to ctx cgen data value is equal to data is equal to yeah, hell yeah. So now in MiLa I also need to free ctx then because not ctx. Well, actually, yeah, it's not. Scheiße. That got me bad. Because in this context, ctx here is actually a cgen data. Ctx here is thread context. Yeah, so now that's actually cgen data. So now cgen data thread context star ctx is equal to cgen data ctx, not cts, ctx value star data is equal to cgen data. So wow, char star get string, while you need to compute. That's size t, so we need to use this size t2. Because of choding, I write it like this because it just looks better. Anyways, thread yield. Char not, it is gonna be data I 0. Will this work? Will this work? So we're gonna, yeah, all of my preferences in programming are mostly looks. So after we do that, we need, yeah, we already did it didn't, oh gee, send me from int, what, unknown type generator. Stay with me, mayonata wa tadaki, maela dai zetto haita. Generator, so we need to, we just dereferenced it. I mean, we not dereferenced. We just casted it a couple of cgen data ctx, that is void star as of, oh yeah, this, no, in MiLa thread worker, MiLa thread worker, it is void star. Huh? Expected cg, oh, yippee. So normal threads, generators still work. Seeing an anime opening, what, wait, I just forgot. I forgot. I know I know a few words of the Tokyo Ghoul opening. Never mind, I'm cringing. Anyway. Anyways. What were we, just a second. We return an integer. Oh, we're in the wrong file. Cgen. We return the, okay, so int thread ID is equal to, oh no, I'm not well, it's fine if I become famous of that. Make cgen, so we're gonna provide ourselves. How kind of me to provide myself. I really need to close my mouth sometimes. So let's see. Yeah, there's no errors. That's correct. It's a correct function type thingy. So it yeah, it adds that. We return the thread ID. Yeah, we return the thread ID, and then we're gonna return our SSV int thid. Please work. Please work. Please work. and then it just explodes. An integer? Was? Are you okay? So on line 3, so that should at least report, yep, iString. What was res? Print value, value debug. Res. I'm such an idiot. I forgot to do that. Example. Here we go. Oh. Value debug. Res. Boom. Seriously? It didn't even run this. Object. Oh. C++. I swear to God. I swear to God. Hello. It just returned the iString. So let me just print value debug. Good. For each. What the hell was that? For each. There we go. So what happened? It didn't even trigger this because this is embarrassing. We forgot to set it here. Oh my goodness. Val set method table. iString meta. So you method to gen outputs. Ah, there it is. There it is. What? Ooh. Okay, so we did get the okay, that's cool. We got the integer. That's the thread ID. That's cool. We got it. The only problem is, let's see. Heap use. Oh, okay. So we overflowed. MiLa worker. So it was allocated by iString to gen. Yeah. So yeah, here in make C gen. And then in MiLa thread worker, something happened. The heap buffer overflow. So it isn't a use after free. It's just out of bounds access. And it doesn't. Oh, okay. Good thing we had that. 167. Get that. Freaking. Oh. We cannot. Oh. Okay. We need to. Boop. Bam. And ooh. Wait, Z. Boop. Bam. And instead of CTX, it's gonna be arc. Bang. No. Wait, no. Not CGen data. Wait, is it CGen data? Yeah, we do receive CGen data. Yeah, CGen data. So, nope. Incompatible. Oh, it's first to be thread context. Wait, what? No! No. 9. Cgen is... Wait, ha? Eh? Oh. What? Ha? Teka nga. Pati ako nalilito. Cgen. So, this actually is thread context. Then... Wait, no. It is Cgen data. But first, we access thread context. CTX. Hello? It is what? Are we programming in Lisp here? That is the problem. The problema. So that is still the same. We can use those to communicate, even though they're different types altogether. That's C for you. That is C for you. So now here, we can go, CTX is Cgen is equal to 0. So now, we can go here to the other one, where we do create a Cgen, make Cgen. We can set a Cgen, okay, so where's the other, yeah, here. Oop. So now, we can just go here. Even though those are different types, if ID reference, if I cast it, and then access the first, field, so what, MiLa thread worker. So we can go here, cast it into a thread context, arg, we can, we can go here and go is Cgen, oh goodness gracious, is Cgen, and negate that. So if it's not Cgen, we go here. We're almost there. So okay, now that works. So let's see. It's a heap use after fudge. Oh, yeah, I see. I immediately got that. So string my built-ins. Okay, so we need to go here. Store copy. Then we just free it here. Oh no, that's a okay, that's not good actually, but who cares? Oh, not store copy, store dupe. So actually oh. Duplicate. Ito to, ha? Huh? What owned OP? Was? So we what do, oh. Yeah, it works. Wanna know why that sleep helped? Because we freed the I string. Here. I'm gonna show you why. We're using threads, right? So we can't. It's not asynchronous. It's not a real generator in a sense. Because look at this. When we call method to gen, it creates the thread. But because the thread does not block, we release it afterwards. Like once we call this, it goes to this immediately. So what happens is when it now iterates the string, it doesn't exist anymore. I mean, it even when we copy the string, because the string itself it doesn't exist anymore. So what we're gonna do is we're gonna free it after the loop. Oh, but the only problem is we can't really... Yeah, that's the only problem. The problem. Yeah, so yeah, that's what happens. The problem. Oh, we already do that there. So, we just... dummy. We do a dummy. So this is what's gonna get freed. So we're gonna go here, value star dummy. Val release doesn't release a pointer if it's null, so we're safe if it is not set. Dummy is equal to iter objects. Stop with your C++ nonsense. So now that should be freed. Yeah. Yep. 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 Yippee. Yeah. So we do that. Oh. No, that's alright. So yeah, we can just, because if it's not set, it won't make a fuss. There it is. Yes, it works. The only problem is it doesn't terminate because it's not a daemon thread. So when we create the thread, so cgen, make cgen, we're gonna make it a daemon. Oh, oops, it's a daemon. So we don't. It still doesn't work. Oh no. Oh no. Please tell me it does exit out of the loop though. Please tell me it does. No. It doesn't. No. What? No. No. Why are you doing this? So close yet so far. Why don't you work? Oh yeah, and also that's some memory leak now because we don't really need. Yeah. Warum, meine Freunde, meine Freunde, warum? So this should work. I have this piece of code in parse string, so that shouldn't fail. And we should, it expects thread yield to return null as the last value, I think. So we need to go here because the loop won't. Yeah, just a second. Yeah, let's just try that. But wait, hey, it worked. Hey, it worked. Yes, it worked. Woo! Oh, wait a second. I saw that. So basically, yeah, it almost worked. So what happens is dummy is equal to 0. So iter object. Yeah, and then we set iter object to the rest. So that should dummy and iter object should be not the same thing. And we don't set dummy anywhere else in the code, and we free them. So if this is null, it does nothing. And if this is the original iterable, and then this is the generator's stuff, it won't die. It won't die with memory. So okay. So what was double? This. Yeah, we freed it there. So now, let's see what leaked. So -3. Where? This? Okay, 11 allocations. Wow. 298 bytes. Where did the 298 bytes come from? So let's see. Vnull. Okay, so this isn't handled. Okay, so it decreased. It's this. Yeah, it's this. It's saying it's in MiLa thread worker. Yeah, it's this. Yeah, look. String length worker. That's, yep, it's this. So, why is it not? Chotto. Mate. So we yield. Yeah, we do, and then we free it. Right? We free it, right? Right? Why won't you work? Warum, mein Freunde, warum? Okay, let's see. So n, where's n? Oh, okay, I missed it. N. Okay, it's 1. It's 1. So why is it leaking it? Dude, I'm so close. I'm so close to actually having generators in here, and it's not working. It's leaking memory. It's the stirred up stuff. So I should just restring take. Oh, that helped. It's still not working. So now, not only did we not free the, okay, it's the, yeah, I know, it's the MiLa itself, the object itself that's not being freed. How come? Thread yield copies it. Doesn't it? Son of a... So yeah, we need to put this in here, value star that tmp. So we're gonna take restring. No, we're gonna change that. Yeah, temp. We're gonna dupe that, and then we're gonna, yeah, it's fine. Val release tmp. That should. Oh, 5 allocations. Okay. What 5 allocations? Hey. Oh, okay, it's that. Okay, so we string dupe. We did it. We did it. It's a generator. We did it. It's an actual generator from C, not just MiLa. So we can implement generators in. We can generate generators in C. So this is in C. We don't need to use MiLa to define the. Holy crap! It works. Woo! It does. Great. Wow. It works. No memory leaks. And we don't copy the string. We don't copy the string. We're using the original string here. So wait, no, I think, yeah, I string. I string, you know, it does duplicate the stuff. Here, let's see. ASCII string argv0. So we just take. Oh, I see. Oh, I see. Yeah, it's gonna segfault. That's alright. The problem is we need to free this somewhere. But yeah, there's memory leaks. So for now, it copies the string. Temporarily though, it temporarily copies the string, and every time we iterate, it doesn't copy the string anymore. So even if this is a gigabyte, it's gonna spike for a bit, and then the original gigabyte string would be reduced. Freed, and then this is the only quote-unquote copy of the gigabyte string, and then when we iterate through it, it won't generate another gigabyte string. It will generate items per iteration. So, yes! This is so exciting, dude. Yes! Woo! It works. Yes, it works. So now we just need to add that here. Oh, that's not there. Here. iString. There we go. So, yes, it works. We got generators. And the funny thing is, oh wait, we can So yeah, as you can see, this is the iterator for normal strings. So we both can use the generator or the iterator. If you use the iterator, oh whoops, I forgot the exit here. If you use the iterator, it's a little bit faster because it just whoops. Yeah, it just iterates to the string, like entirely. It returns here, as you can see, it returns a list, as I just said in earlier. It returns a null terminated list of value instances. This generates them one by one, only when needed. Let's go! Whoa! Let's go! Yeah, that works. Yes! Yes! Woo! Woo! Let's go! Wow! Whew, yeah. Say lolcat, coffee breaks, sentinels, generators. Yeah. That's about everything that we did. And also, made the food pellets circles. That's also counted. So yeah. Woo! Oh, and fixing the bindings generator as well. Yeah. We got it working. That's so cool. So, wow. Singing content. Stay with me, mayonata wa tadaki, maila zai zetto haita. Stay with me. Anyways. Yeah. But Joding, where are you, Mr. Azozin? Mr. Azozin, where are you to criticize my code? That was very bad Slavic accent right there. So yeah, generators. Oh yeah, range function also has an iterator. Range. Yeah, native range. Oop. So yeah, where's the iterator? Range iterator, same as the string iString iterator, And the nice thing is, you can actually see the range. So if I may come here, and let's say 0 to 10, and then we step by 2, and then we print that, it prints the range, how you called it. No, not literally how you call it, but what arguments you passed into it. So yeah, unlike Python, which the range function just returns that oh wait, eh? It does that now? What? Okay, what? When did that? Huh? What? I'm getting old. What? When did? Huh? When did that? When did they update that? I precisely remember that. When did they... Am I misremembering a bunch of... There's no way. There's no way. I'm going to my PyDroid on my phone. There's no way. I remember it saying range objects. Wait, no, this is Python 3.13. So yeah, I can't really... When? When? What when? Why is it so slow? When? What? Huh? Oh. When? When did they... What? Huh. What the hell? What? I do not remember. I do not remember that. When did they update? What? I'm getting a Mandela effect here. I'm getting the Mandela effect. I precisely remember. Ranges. Not displaying their content. Their ranges. Basically, yeah, the range object. It just says range object. When did they update that? That's actually pretty convenient, but when? What? Or is it only in the repo? I think it's only in the repo. But, huh? Oh, whoops. What? When? What? When did they update that? What? What? That's 3. Okay, so hello. Oh, this is a dark mode. Okay, I forgot that my it. Okay. Hello. Run, please run. Oh, there's different ones as well. I can't click. I can't. Oh, they're buttons. It takes too long. Shush. Shush, I don't want to. Let's see it. That's 3.14. 3.9. Execute. Years. Greedy people. Oh, okay. So we have 3.10 now. PyInv. PyInv local 3.10. So now Python 3-v is 3.10. So Python 3 range 90. When did what? There's no way. There is no way. Oh, hello. I'm just having an existential... Oh, I see. I'm having existential crisis right now. Because I remember ranges in Python did not used to have that representation. What? I'm checking everywhere. When did they... What? Shush. Ah. When did they add that representation in range objects in Python? I'm having an existential crisis. See? So, wait, you're telling me I used Python... Wait, what? Huh? Eh? You're telling me I was using a version of Python that was older than me. Because I remember. Yeah, see? See? This is what I meant. What? Yeah, but they didn't have that representation. I remember being in the repo and seeing this. What? My brain is what? I cannot accept it. What? What? Huh? Eh? Kailan nangyari? What? I'm resetting to my mother tongue because what? Eh? I'm having a Mandela effect. Did I fall into a wormhole or something? What the hell? Like, yeah, this was... How? How did I had an experience of being able to see that range object thing. What? What? I am an old man stuck in a young body. What the hell? It's not even a young body. My back aches, knee aches, everything aches. I've achieved what a person would achieve in their 80s. Also insomnia. What the hell? I remember what? Eh? Okay, anyways, let's move on. Yeah, I think I may need to go. I did say I was gonna stop at 10:30, and now it's 10:55. So yeah, power of unhealthy lives. Yeah, I have to go. No, Bob. Yeah, I have to go now. Yeah, I've been also drinking coffee since earlier. Yeah. Let's check how long the stream. Well, okay, that's 4 hours. 4 hours right there, and there was 2 viewers at some point. So, anyways, yeah. Ciao. See you in the next stream, and thank you for sticking with me. Bye.